So in this session I will give an introduction to EuroForMix. I will talk about why we developed EuroForMix, what it is, and what it is able to do. So I will now talk about the motivation for developing EuroForMix. So now consider a two-person mixture evidence profile, where we can see that there are two large peak heights and two small peak heights. So the qualitative information is given as 15, 16, 17, 18. And this is the information which EuroForMix uses in the model. Here the contributors can have several genotype combinations. For instance, 15, 16 and 17, 18, 15, 17 and 16, 18, and so on. We can see in this example here that the peak heights would give extra quantitative information since they reflect the amount of DNA coming from each contributors. The contributors are more likely to have the genotype combination 15, 18 and 16, 17 since the peak heights are giving extra information to who is the major component and who is the minor component. So code A is that we can calculate the weight of evidence of whether a suspect S is a contributor to the evidence or not, using the qualitative information. So if S has rare alleles, which is in the evidence, this will give more support and higher LR. Code B, in addition, we should look closely on the peak heights and see if we can deduce the genotypes for any of the unknown contributors. Here, the aim is to find the genotype combination for the unknowns, which are more likely than others, and also check that the genotypes of S may agree or disagree with the peak heights. So the issue here is how can we include the peak height information in the weight of evidence quantification? So the formulas let G denote the set of genotypes for the contributors to the evidence profile E. So for instance, the observed profile is 15, 16, 17, 18, and the proposed set of genotypes is 15, 18, 16, 17, for instance. And for a given hypothesis, some of the contributors may be known. For instance, the suspect is known under HP, while the rest are unknown. And under HD, we may have that all contributors are unknown. So now let the genotype probability for the contributors be given as this expression. And this is typically inferred from the allele frequencies sampled in a population. Now let W be a weight assigned for each genotype combination of G. So we say that this weight is designed to say how likely it is to observe the data in the evidence given a proposed genotype combination G. So it's a weight taking both the observed data and the proposed genotype G. And for complicated evidence profiles, the weight is this weight here. It's modeled through a statistical model with parameters beta. So the weight is getting depending also on unknown model parameters. So we can now construct the LR from this, and by traversing over all possible genotype combination under each of the hypotheses. So the first part of this expression is the weight, and the second part of the expression is the probability of the genotypes. We have also the model parameters belonging to each of the hypotheses. The formula is different for EuroForMix and EuroForMix. So by assuming that the genotype combination G spans over all observed alleles in E, and then we can write the weight here as the product of all the alleles in E. So for the qualitative model, this probability is the probability that A has not dropped out given the proposed G, and where the model parameter beta are the level of dropout probability. For the quantitative model, this probability of the allele is given by the peak height and also the proposed G and the unknown model parameters beta. So here this function f is a peak height distribution for the allele A, and the distribution here, it is decided by the parameter beta. For instance, we can have a gamma distribution for f, and the shape of this curve will be decided by the parameters beta. So there are already existing software for having a model which includes the peak heights. So we have developed a software which is both open source and also include a GUI. So now I will talk about what EuroForMix is. It's a software for forensic experts to calculate the likelihood ratio, where a statistical model for the p-kite is included, and also for doing other interpretations. So in this plot we see the import data panel, where all the data are imported, and the second panel here is the model specification, where you set up the contributors under HP and which one are unknown under HG, and also for selecting degradation model and stutter model. And you can also decide which procedure for calculating LR you want to follow. So EuroForMix is published in 3 papers. It's 2 research papers and extended abstract. So in the first paper is a technical description of EuroForMix, while the third one is a comparison study where we evaluate EuroForMix against LRMix. So EuroForMix has also a web page. Here you will find the latest version of EuroForMix. So the statistical p-kite model of EuroForMix implement and it extends the p-kite model from Cowell 2015. Here the p-kites are assumed gamma distributed, and the gamma distribution takes the shape and scale arguments. So the procedure is to tweak the parameters in the shape and scale arguments to be selected such that they are the most likely ones to explain the observed p-kites. And this is the maximum likelihood procedure. So the model features of EuroForMix is that it can assume multiple contributors. And here you can condition on any number of reference profiles, and you can specify any number of unknowns. However, there is a practical limit of 4. The model extensions is that EuroForMix can handle allele dropout, allele drop-in, backward stutters, degradation slope, and also subpopulation structure. So EuroForMix can also handle replicated samples, and this means that you don't need to make a consensus sample. However, the model assumes the same contributors and also the same p-kite properties for each replicates. So the unknown parameters in the model, it's the mixed proportions for contributor 1, contributor 2, etc., depending on how many contributors you are specifying, and it will be related to the proportion of DNA from each of the contributors. And so the p-kite expectation parameter, this is the expected p-kite for a single heterozygote allele without degradation. And for the p-kite variability parameter, this is given as the coefficient of variation of the p-kite for a single heterozygote allele without degradation. It will be a standardized measure which will be independent of the size of the p-kites. Next we have the stutter proportion parameter. This is a global parameters which is related to the n-1 stutters, and this is given as the expected fraction of a p-kite that is stutter. The degradation slope parameter is a parameter related to the degree of decaying degradation, which is global for all contributors. So first we recap the likelihood ratio formula, and as we remember here, there was a parameter beta which was included in this formula here. What we want to do is to decide these unknown parameters with respect to the observed data. So for LRMix, beta is the dropout probability, which is assumed to be equal under both hypotheses. And this beta is inferred to be a 5% quantile, which is estimated using a Monte Carlo simulation. For EuroForMix, beta is the model parameters from the last slide, which determines the p-kite distribution, mixture proportions, stutter distribution, degradation slope trend, and this beta is decided to be the maximum likelihood estimates under each hypothesis. And in addition, a sensitivity analysis can be carried out to provide conservative LR values similarly as for LRMix. The approximate time usage for EuroForMix in order to calculate the LR is that for one unknown contributor takes about 1 second, 2 unknown contributors takes about 1 minute, and 3 unknown contributors about 30 minutes, and 4 unknown contributors about 1 day. So EuroForMix also contains a lot of functionalities. So first of all, it contains data visualization and allele comparison. So for this evidence profile here, you can see all of the imported data, alleles, and the corresponding p-kites. And also for the references, all of the alleles, and also a quick comparison with the number of alleles which are included in the evidence. With the total sum here. The visualization of the p-kites are carried out in a EPG-like plot like this, where all the references are labeled, denoting which alleles they are having. So for instance, 1/2 means that they share one allele. And also it contains a GUI for doing weight of evidence calculation. So the aim here is to check whether a suspect is a contributor to the profile, and the likelihood ratio for this is carried out and visualized in a table. It also contains functionality for doing deconvolution. Here, the probabilities of the locus genotypes for the unknown contributors are calculated. So by including a evidence profile, the genotype profiles of the unknown contributors are predicted and given in a table like this with the most likely genotype with the probability, and this is done for each marker and each unknown contributor, C1 and C2. EuroForMix also provide a function for database searching, so it uses both quantitative model and also the qualitative model, and also the number of matching alleles. As you can see here, for a given database with a lot of reference profiles is compared with a complex DNA profile, and the result is a ranked table ranked with the selected criteria here. And as for conclusion, the advantages of EuroForMix is that it is flexible to the input data, so it can use any kit system and any number of markers, for instance SNPs as well. It can handle any number of replicates. However, it is restricted to be constant parameters across all replicates and also any population frequencies. And it's a flexible model. It contains a model for backstutters, and this can be turned off or turned on. And it also includes a model for global degradation trend, which also can be turned off or turned on. And the model properties are selected to be the one which are best explaining the observations. That is the maximum likelihood. This implies that the p-kite distribution is fitted through the observed p-kites, and that the drop-in are taken care of through the fitted p-kite distribution. Also, the uncertainty of the model parameters can be taken into account in LR. It also includes a deconvolution procedure and a database search procedure. The disadvantage of EuroForMix is that it's effective only up to 4 contributors. However, when we turn off the stutter model, it will speed the procedure drastically. There are also model limitations in that it is possible that markers have different amplification efficiency, which is not taken into account. Forward stutters are not included, and backward stutters, they follow always the same distributions for all alleles for a given amount of DNA. And in the deconvolution module, we are not able to take into account the uncertainty of the model parameters.